Welcome to a new session of analog circuits. In our future classes, we are going to deal about analog circuits in depth, the applications of transistors, diodes in different electronic fields. So we are going to treat this class as class 1. We are going to understand what is meant by a forward bias and a reverse bias and how the characteristics would be. So we'll start with the concept of diode. A diode is formed with the help of p-type and n-type material that everyone knows that. And this side of the diode is known as anode and the outer side is known as the cathode. Now under forward bias, when you apply a input supply to a resistor through a diode which acts like a switch, this is how the forward bias uh, direction of current would be. And in the reverse bias, the diode you can see it is reverse bias where the cathode is connected to the positive terminal of the input supply voltage. And also you need to keep in your mind that the cut-in voltage or what we call as the knee voltage for germanium material is 0.3 volts, whereas for silicon it is 0.7 volts. And what we should keep in our mind, the forward resistance is in the order of ohms, whereas the reverse resistance is in the order of mega ohms. We are going to deal with in-depth knowledge of about all the characteristics about the diode and how germanium and silicon are acting as the semiconductor devices under this formation of p-n junction diode. So when you look into the VI characteristics, you can see that you have a forward current, you have a forward voltage, whereas a reverse voltage and the reverse current are shown in the negative x and y directions. Under germanium, under new voltage of 0.3 volts, this is how the characteristics would be under forward bias. And for the silicon, this is how the characteristics would be for silicon material. So the new voltage is 0.7 volts, whereas the reverse conditions, you can see there is no sudden change in current at the initial stage, whereas at the later stage there is a drastic change in the current. All these things happens because of the resistive nature of the diode. So when you look into the characteristics under forward bias and reverse bias, what we need to know is that during forward bias, gradually increase the voltage in small step of order 0.1 volt, means step by step you increase the value of voltage and correspondingly you observe the value of current. Now up till the knee voltage, what we call as the cut-in voltage for germanium, that is 0.3 volts and 0.7 volts for silicon, there is no diode current due to the fact that externally applied voltage is opposed by the junction voltage. Now what is junction voltage, what is junction barrier, we are going to see in our future classes. Now as the voltage is increased above the knee voltage, the diode current increases rapidly, and that is what we have seen in this characteristics. Here you can see the current after the knee voltage under germanium or silicon, it is increased in this fashion. Okay, under reverse bias, the reverse resistance is high. Why the reverse resistance is high, we are going to see in our future classes. And the current is due to the minority charge carriers. Now what is this minority charge carriers? This is also an important fact. Now practically no current flows through the circuit, and for large applied reverse bias, the kinetic energy of the electrons becomes so high and they knock out electrons from semiconductor atoms. And at this stage, the breakdown of the junction occurs and there is a sudden rise of reverse current. And that is what we have seen in the reverse characteristics. Fine. Now, pertaining to the input supply, when I change to a sinusoidal input like in this fashion, where I can see the practical application of diode, how the output of the resistor would be obtained with the help of input voltage when it is applied to AC, that would be an interesting fact. So again drawing the axis for input voltage and output voltage like this for both the conditions under forward bias and reverse bias. And since it's an AC source, so I'll be having the supply of AC in this fashion. In both the conditions, you can see the AC signal, it is alternating in nature in both the cases. Whereas you are going to see the application of the diode, what it does, it will only allow the positive voltage, okay, to pass through the diode, and the voltage across resistor would be in this fashion. So this is a half-wave rectifier output. I think I'm clear about this. What happens when the diode is reverse bias? When the diode is reverse bias like this, you can see that the output voltage across the resistor would be like this. So this is an interesting fact. In order to understand in a better way, let me take the example of MATLAB. See here, I have taken different conditions. You can see here I have a DC input voltage of 100 volts, okay, and a diode is connected, and here this is known as current measurement, this is known as voltage measurement. The current is calculated through the circuit and voltage is measured across the resistor. And when you apply the voltage to this resistor whose value is 20 ohms, just imagine this is 100 and this is 20, right? So roughly the value of voltage and resistor will give you the value of current, that is I is equal to V by R. V is 100 and R is 20. So approximately I should get the value of current as 5 amperes. So here you can see the current waveform is shown over the scope over here. See this current here. The current here is approximately 5 amperes. And the voltage, that is only the positive voltage, it is reached to the 100. You can see here 99.195. This have run like this. So this is under forward bias condition. In order to understand in a better way, what we have done, we have taken a source voltage like this. Input voltage is 100 at a frequency of 50 hertz. Okay, the same voltage from DC it is changed to AC, and this voltage source represents the actual output of the AC voltage, and that is being applied through this go and for tool from the MATLAB. And here you can see 100 volts is applied as an input and the output is obtained in this fashion. I think this is clear. Whereas the current, if at all you see here the current through the resistor is 5 amperes. That is what we got, right? 5 amperes, 100, 5. Why? Because input is 100, resistance is 20. Then actually the current waveform would be 5 amperes. Okay, what happens if I reverse this diode? See here I have reversed the diode. These are the parameters of the diode. By default, MATLAB will take some parameters of diode in this fashion. So you can change these values to your requirement. Don't put any zeros. Just put different values and check out the output conditions. So what is the ideology here? I have taken the input voltage source as 100 and the resistance is 20. Then what should be the output? You see here. See, this is the output voltage and this is the output current. The output current, since the reverse bias, it is shown as -5. Okay, and the output voltage across resistor under reverse bias, you can see here it is obtained as -100. That what you can see here. Over here also you can see this graph is shown in this fashion. So this is now this is how you need to understand the behavior of the diode. Once this concept is clear, that is the diode concept is clear, you can easily understand in detail about the transistors, whether it is bipolar junction or whether it is MOSFET or any IGBT. The ultimate logic of applying these devices, we are using these devices for small power applications as well as for high power applications, generally as switching devices. So if at all you look into the final way of forward bias and reverse bias under input as 100 volts, this is how you got the output of the voltage across the resistor under forward bias and under reverse bias. So that is a practical application of the diode as half-wave rectifier. I hope you like this class. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications. Thank you.